Hello folks, and welcome to this video which is all about work done. In this we're going to learn a couple of equations and then see some example questions which are all related to this topic. So let's get started. Work is a concept which is used in many different ways. You'll be aware, of course, that we relate it to jobs, to homework, etc. But in physics, work has a very specific definition. And we define work in the following way. It is the transfer of an energy when we use a force over a distance d. Now, in a second, we're going to dive into this, but I'll just show you the equation that we use to calculate this. We use the equation in this form: work W is equal to force F times D times, and this is the little tricky part, cos of theta. Now, hopefully you're familiar with cos from your maths classes. If you're not, it's simply a button on your calculator that you can use. And if you're having any trouble with this, please do let me know. What do we mean by this? If we look here, we might have a force F, which is in green there, and that might cause my blue block to travel a distance d. Now you notice there that they have an angle between them, and that angle there is theta. Okay, now the result of the force acting over this distance may be that the block moves in the horizontal direction. Okay, so by doing that, we are transferring energy, and this would most likely be stored as kinetic energy in the block. For example, we might be causing this thing to speed up. Okay, so just to be clear here, theta, okay, that symbol there is theta, is the angle between the direction of the force and the distance traveled. So if you're given a problem and it's clear that the force and the distance are not in the same direction, then you're going to have to think about what that angle theta means. And we'll see an example in a second. Sometimes, however, it's made nice and easy for us in the case where the force and the distance are parallel. In this case, theta is equal to 0. Okay, in this case, that's when the maximum work is done. When theta equals 0, the maximum work is done. In other words, when the force and the distance have the same direction, we do maximum work. Now in this case, the equation actually becomes a lot simpler. It becomes W equal to FD. Okay, now the reason for this, if you're familiar with cosines and sines, is because cos of 0 is simply equal to 1, and so that cos disappears. So for the majority of the time, you're going to be dealing with the simpler version of this equation, W equal FD, and that is when theta equals 0. However, you do need to be aware that if the theta is non-zero, then we have to modify using the cos term. So I suggest it's good to know. All right. Now what we're going to do is we're going to see how this kind of translates into questions where you're asked to calculate work done. So let's try a couple. Let's imagine we've got 50 newtons and we are going to move a block by 30 meters. Nice simple numbers here. This is just to demonstrate the ideas here and how we do the calculations. Now we're going to try one situation here, and that's where the force and the distance are parallel. In other words, theta equals 0. So what I'd like you to do, if you're in my lesson right now, is pause the video and try this question. Write down your working in your book and make sure you're ready to see my answer and compare with yours. Hopefully you've taken the time to pause the video now and you're ready to see the answer. The way that we would do this, because the theta is 0, we've got the simple version of the equation, which is W equal to FD. And all we have to do is simply multiply 50 by 30 to get 1,500. So when we're doing our work, in this case, it's a simple process, 50 times 30, force times distance. Our units there are joules, because work is a transfer of energy, and so therefore it must have the same units of energy, and that's joules. Now we're just going to do the same question, but this time we're going to imagine that there is an angle, a non-zero angle between the two, and in this case we've got an angle of 45 degrees. Okay, again, I suggest, if you're in my lesson, to pause. Try this using your calculator. You're going to have to use a more complicated version of the equation. And then once you're ready to go, press play and see what the answer is. Press pause now. Okay, let's have a look at the answer. All right. Obviously, we're going to use the complex version, which is W equal to FD cos theta. The F and the D do not change during this. However, what changes is we need to include that factor of cos of 45. Now, putting that into your calculator, you should have got cos 45 is equal to something like 0.7, 1 over root 2. And what that then does is reduces my answer. Notice here we're still giving an answer in joules. However, it is a lower value, and that's because we know that as that angle increases, we do less work. We transfer less energy. So one small check you can do when you're doing these kind of slightly trickier problems where theta is not 0, you can check with the theta 0 case. You can see that that amount of work reduces. That's because the maximum work is done when theta is 0. All right, that's all for now. What you're going to do next is a little bit of more practice independently. You're going to build up your skills and be ready to show me that you have mastered this content. Thanks for watching, and if there's anything unclear, feel free to watch again or let me know if there's anything else I can make clearer.